Welcome back. So in this video we're going to be looking at this little section here. Well, big section, but we won't be going into detail into some of it. So the first little function here is display board. So this is quite an essential one. It shows the board to the user, obviously, and it's only past one variable. It's just past the board variable, so you can see what's on the board and where it is. So if we scroll down, this is around here. So it's not too big. There's lots of console.write lines in there. So again, like initialize board, we have two variables being declared at the start, ranked number and file number. So these are going to be stepper variables, just like they were in the old one. So we have console.write line just to clear a space above where the board's going to be printed, and we start the main area, which is these for loops. So one for loop here and one for loop here. Now the first one is going to iterate down each rank. So obviously when you print a line, that will go down to the next line. So we need to print the ranks first and the files in each rank. So we look at the rank things. It writes this line, which is a well, it's just a line really of underscores. But it has a bit of a space before this, so that the board is kind of spaced from the edge of the screen, just to make it look a bit nicer. And also to make space for this room here, this line. So this does is it looks at the rank number, and it says, I want you to print that rank number, and then put some spaces after it. So that is how, when we're running the game, we get these numbers down the side of the board here. So each number just tells you what the rank is, so you don't have to be counting squares to find your coordinate. And so after that we have another for loop, which is to go through each rank from left to right. So we say file number equals 1 to the board dimension, which remember is a constant, which means 8 in this context, and that's used in both these for loops. So for each file we write one of these characters, which, if you're wondering where it is, it's just next to Z on your keyboard if you use the Shift key. I'm only saying that because it's just a very rare character to see, but it's very useful. So it's going to print this vertical line, and then it's going to print whatever value is in that space in the board. So we use rank number and file number, and we look at that value, and we put that into the console when we write it. So if we have a look, remember in the sample game in each corner is the gizg here, and so in the first one that it prints it says, let's have a look at that value. So we know that is a black gizg here, and so it's a BG, so that space in the board array is BG, so it just prints BG and then goes on to the next file. And that's just how it prints the board. It's very simple. It iterates through and it goes, for each rank it goes across and then down and then across then down then across then down. It just carries on doing that until you get to the bottom. Once you get to the bottom, it finishes off the board with a underscore line, which matches the top one just to make sure it's a nice closed grid. It writes another line and then puts this row of numbers underneath, which obviously, of course, is the same reason as this line up here, which is printing the rank numbers. And that's just so it's much easier to see what coordinates a piece is in and pick it using when you're making your move. So the next little sub here is just called display whose turn it is, and that's a very, very, very tiny little sub. It's just hiding here below the main sub. So it's passed whose turn as by value, which means that it can just look at whose turn it is and not change it. So it says if whose turn equals W, then it's white's turn, else if it's not, then it's black's turn. So that's quite simple. In fact, I'm not even going to go any further. So after that we have this section, which is the move validation section. So it gets the move, it passes the input, and then it checks if that move is legal or not. So we're going to start off by setting move is legal to false to make sure we don't get any false positives. And then it's going to run this sub which says get move. And I'm not sure exactly where this is in the program, so I'm just going to scroll down until I see something that looks like it. It's not here, it's not here. So there it is. So this is it's just a simple sub. It uses two questions using console.write, and it just assigns start square and finish square the value which is put in by the user using readline. So this does each of those. It asks you to put the file first. Remember, we use that maths to get the rank and file out of the number, so we need to make sure they're in the right order when we give them. So that's quite simple. It just finds a value for start square and finish square. So obviously they're passed by reference, so that this function can change them. So if you go back up to the top, we see this maths here again, which we've gone through, and so that'll just get the rank and the file for each coordinate that we're referencing. And then we run check move is legal. So this function is past the board array, the start rank and start file, and the finish rank and finish file. So it's past those two coordinates and the board itself, and also whose turn it is. So it's past 6 different parameters for this function. It's just a set of Boolean values. So we'll just have a quick look at the structure of that subroutine, and then we'll go through in details in the next video. So if we look here, it starts off by finding what piece type and what piece color is in that space on the board referenced by finish file and the finish coordinate and the start coordinate. So if you look here in check, so if we look here in check move is legal, we can see it's setting up two local variables of piece type and piece color. So what this is going to be used for is to find which piece and which type it is which is being moved. So it's whichever one is in the start square, and that's just so it can make sure it uses the right kind of validation for that piece. It starts off with a very simple if command, just in case you've messed up, and it checks if finish file equals start file and finish rank equals start rank. So basically, if you're trying to move to the same place, obviously you can't do that, that's ridiculous, and so it just immediately returns false. So that means that sets move is equal to false, and so it'll ask for another move up in the main subroutine. So after that, we assign piece type and piece color. We do that by using we use the fact that it's a string, and we use some little. It's almost treating it like an array. So an array of characters almost. So when we're looking at piece type, so remember, for piece type we want the second character in each square, because we have the white or black in the first character, and then we have R, E, N, M, or S, or whatever, in the second character. And so what we use is, we look at that square, say board, start rank, start file. So we're looking at that set of two characters together, and we're saying, I want to just get this character from it. So in computing, we often use 0 as the start index. So instead of counting from 1, we count from 0. And so in this instance, when we're finding the piece type, which is the second character, we look at the character with index 1. And that's a bit easier to understand when we look at piece color, which is obviously the first one, is whether it's white or black. And so it'll look at it and it'll say board, start rank, start file, brackets 0. So it's looking at the very first index of that string, which is contained in the board. So it's just taking those values out of there and getting even more information separated out so we can use it individually rather than together. We'll just go through this section here, and then we'll look at this bit in the next video. So if you have a look at this, if whose turn equals W, so we're saying if it's white's turn, and if the piece color that's being selected, so remember this is in the start square, so if we're selecting a piece which isn't white, remember this equals not equal, so if the piece we're moving is not white and it's white's turn, then obviously you can't do that, you can't move someone else's piece. So it returns false. We can't make that move. But if foo7 is white and if the finish file, and we're using this index thing again. We're saying if the 0 index of this string in the finish square, so we're using the finish coordinates now, is also white, then you can't make that move either, because you can't take your own piece, obviously. And it does the same thing for the black pieces, using this else statement here. And that's just a simple end thing to prevent any silly mistakes with taking your own pieces or moving someone else's pieces. Now, this section here is to make sure that each piece is being moved in the correct manner, and we'll look at that in the next video. Thank you for watching.